Okay, so good day everyone. So for today, we're going to have a discussion of our quantitative methods course outline. So to start with, once again, good morning and good day everyone, and welcome to quantitative methods course for this semester. I am Dr. Marmel Abante, and I will be your professor for the entire semester for quantitative methods course. No? So the course description, quantitative methods refer to the set of statistical and mathematical techniques used to analyze and interpret data in order to draw conclusions and make predictions. In the course on the quantitative methods, a student can expect to learn about various statistical tools such as hypothesis testing, regression analysis, and data visualization, and how to apply these techniques to a real-world problems. The course may cover topics such as probability theory, descriptive statistics, inferential statistics, statistical model, and experimental design. The student may also learn how to use statistical software such as R, SPSS, or Stata. Throughout the course, the student will be expected to work with data sets and apply the techniques they have learned to analyze and interpret the data. And this may be involved conducting experiments, collecting, analyzing survey data, or working with publicly available data sets. So by the end of the course, the students should be able to understand and apply the concepts and methods of quantitative analysis to a variety of research questions and problems. And they should also be able to effectively communicate their findings and conclusion using appropriate statistical methods and visualization. The specific objectives of a course on a quantitative methods may vary depending on the institution and the level of the course, but some common objectives include understanding the principles of probability theory and statistical inference, including hypothesis testing, confidence intervals, and significance testing. Developing proficiency in statistical software tool commonly used in quantitative analysis, such as R, SPSS, or Stata. Learning to design and conduct experiments and surveys and to collect and analyze data from these sources. Understand the principle of statistical modeling, including linear and logistic regression, time series analysis, and other multivariate methods. Developing skills in data visualization and communication of statistical findings, including the use of graphs, tables, and statistical summaries. Apply quantitative methods to real-world problems such as business decision-making, policy analysis, and social research. Developing critical thinking and problem-solving skills through the analysis of complex data sets and the application of statistical methods. And appreciating the limitations and assumptions of quantitative analysis and understanding when and how to apply different statistical methods to address different research questions. Overall, the course aims to provide students with a solid foundations in quantitative methods, enabling them to use these tools effectively in their future academics and professional work. So this will be the typical quantitative methods course. Include Module 1, Introduction to Quantitative Methods. Subtopics include definition of quantitative methods, importance of quantitative methods in research, and overview of statistical analysis and its role in quantitative methods. For Module 2, descriptive statistics, of course, measure of central tendency, cover the mean, median, mode, measure of dispersion, range, variance, standard deviation, measures of shape, skewness, and curtices. Then module number 3, probability theory, probability description functions, include the binomial, Poisson, normal, and others. Bayes theorem, hypothesis testing, and for module number 4, that was focused on inferential statistics. Subtopics include confidence intervals, one sample and two sample t-test, analysis of variance, correlation and regression analysis. And module number 5, multivariate analysis, factor analysis, cluster analysis, and discriminant analysis. For module number 6, research design and sampling techniques. So sampling techniques, experimental and experimental design, and survey research design. For module 7, computer applications in quantitative methods, SPSS or other statistical software, data management and analysis. And for week number 8, ethics and professional standard in quantitative methods, covered research ethics, publication ethics, and professional standard for data collection and analysis. So the specific topic covered in qualitative method course may vary depending on the level of the course. And since you are undergraduate student, we'll be able to cover all what we have mentioned earlier. Okay? So, okay. I just want to start on lecture based on our module number 1. Quantitative methods are essential in research because they provide a systematic and objective approach to gathering, analyzing, and interpreting data. And these methods involve the use of statistical techniques and mathematical models to measure and quantify data, allowing researchers to draw conclusions and make predictions based on the empirical evidence. So there are some reasons why quantitative methods are so important in research. Number 1 is the objectivity, because one of the main advantages of quantitative method is that they provide an objective approach to research. So by using statistical analysis to measure and analyze data, researchers can avoid bias and ensure that their findings are based on the empirical evidence rather than personal opinions or beliefs. Number 2 is the precision. No? Quantitative methods allow researchers to measure and quantify data with a high degree of precision. This is particularly important when studying large populations when attempting to identify small differences or changes in data over time. Number 3 is the replicability, no? Because quantitative methods involve systematic and objective data collections and analysis, and they are highly replicable. This means that other researchers can repeat the study using the same methods and obtain similar results. No? Number 4 is generalizability. No? Quantitative methods allow researchers to generalize their findings to larger populations. By selecting a representative sample and using statistical techniques to analyze the data. So researchers can make predictions about how a larger populations would behave or respond to a particular intervention. Number 5 is testability. So, quantitative methods allows researchers to test hypotheses and theories using empirical evidence. So, by collecting and analyzing data, researcher can determine whether their hypotheses are supported or refuted by the evidence. And number 6, efficiency. So quantitative methods, no, are often more efficient than qualitative methods, particularly when studying large population. By using standardized surveys or questionnaires, researchers can collect a large amount of data in a relatively short amount of time. So again, quantitative methods are essential in research because they provide a systematic and objective approach to gathering, analyzing, and interpreting data. They allow researchers to avoid bias, measure and quantify data with precision, generalize findings to larger populations, and test hypotheses and theories, and do so in an efficient and replicable manner. So, an overview of statistical analysis and its role in quantitative methods. Again, statistical analysis plays a crucial role in quantitative methods as it provides a way to make sense of the data that has been collected. Statistical analysis involves using mathematical tools and techniques to organize, analyze, and interpret data, making it possible to draw meaningful conclusions from the data. Actually, there are different types of statistical analysis that can be used in quantitative methods, including descriptive statistics, inferential statistics, and modeling techniques. So an overview of this type of statistical analysis, no, for descriptive statistics, it involves summarizing and describing the main feature of the data that has been collected. And this includes measures of central tendency by getting mean, median, or mode, and measures of dispersion like standard deviation or variance. For descriptive statistics is useful or are useful for providing a snapshot of the data and for identifying patterns or trends. And number two, of course, is the inferential statistics. So it involves using the data that has been collected from a sample to make inferences about the larger population. This involves using probability theory to estimate the likelihood that a particular result could have occurred by chance because inferential statistics are used to test hypotheses, make predictions, and draw conclusions about the population based on the sample data. And the last one is the modeling techniques. It involves using statistical models to represent relationships between variables in the data. And these include linear regression models, logistic regression models, and ANOVA or analysis of variance model. So logistic regression models and ANOVA models, among others. So modeling techniques are used to identify patterns or relationship in the data and to make decisions or predictions rather about future outcomes. So the role of statistical analysis plays a critical role in quantitative methods by providing a framework for collecting, organizing, analyzing, interpreting, and presenting of data. It helps researchers and practitioners to draw meaningful conclusions, make predictions, and inform decision-making based on the data. So, quantitative methods refer to the collection of and analysis or numerical data to answer research question or test hypothesis, as I mentioned. So, it involves the use of statistical analysis and mathematical modeling to measure, quantify, and analyze data. Again, quantitative methods are widely used in many different fields, including social science, business, health sciences, and engineering, to name a few. And these methods are particularly useful when studying large population or when attempting to identify patterns or relationship between variables. Several steps involved in quantitative research process. Number one, of course, defining the research question. The first step in a research project is to clearly define the research question or problem that you want to investigate. Number two, selecting a sample. Once you have defined your research question, you need to select a representative sample from the population you are studying. And this is typically done through random sampling techniques. Number three, collecting data. So data can be collected through a variety of methods, including surveys, questionnaires, experiments, or observational studies. Number four is analyzing data. Once the data has been collected, it needs to be analyzed using statistical methods to identify patterns and relationship between variables. And number five, drawing conclusions. No? Based on the result of the data analysis, you can draw conclusion and make a recommendation. Some common quantitative methods include surveys, as I mentioned. Surveys involve asking a set of standardized questions to a sample of individuals in order to collect data on their attitudes, beliefs, or behaviors. So sometimes survey questionnaire is just not standardized. Sometimes we crafted our own questionnaires for survey. So if we crafted our own survey questionnaire, it is needed for us to conduct a pilot study prior to your actual survey or before the prior actual survey, no, given to your target respondents or participant of the study. Another is experiment, because experiments involve manipulating one or more variables in a controlled setting to measure the effect on other variables. Let's say, for example, in our case as an IT practitioner, no, we must commonly use experimental research. Let's say, for example, you just try to evaluate if you wanted to apply a computerized, let's say, tools, no, in studying mathematics. So maybe you have two groups, no, one using your mobile app, let's say, for example, in learning mathematics in the modern world, and one group maybe no using or not traditional, no, teaching mathematics in the modern world in a traditional way. So again, quantitative methods involves no? Or again, another after experiment will be the observational studies, no? Observational studies involve observing and recording data on a particular phenomenon without manipulating any variables. And number 4 is statistical analysis. So it involves using mathematical technique to analyze data such as calculating means, standard deviation, and correlations. So, quantitative methods involve the collection and analysis of numerical data to answer research question or test hypothesis. And these methods are particularly used when studying large population or when attempting to identify patterns of relationship between variables. I just want to share a video presentation actually, no? Wherein you could able to have a deep understanding on what I have mentioned earlier. And this video presentation is actually available in YouTube, no? This will be the introduction to quantitative analysis by Mark Gavor, no? And actually this is available as I mentioned in. But I just want to share it with you for you to have a more deep understanding on the introduction to quantitative analysis.
We'd like to cover chapter 1 of the Render-Stare-Hanna book, Introduction to Quantitative Analysis. You'll find that most of these videos I basically skip the learning objectives and the chapter outline too much. We'll cover this entire chapter, however. So, mathematical tools have been used for centuries, thousands of years, as they say here, from Pythagoras and the ancient Egyptians using the Pythagorean theorem before Pythagoras actually codified it, to find the area of lands and survey out land. So we use, if we can put numbers into the real situation into some sort of numerical model, it's a good thing. It's not just enough, as it says here, to know the mathematical techniques, but you have to have some subject matter expertise of what you're trying to do and make some judgment that what you've modeled mathematically represents reality in a way that you can actually use it. And then if you've determined that, you have a tremendous advantage in having a mathematical or quantitative model. There's countless stories of this. There's a few examples from our old textbook. In the mid-90s, Taco Bell saved $150 million using forecasting and scheduling quantitative analysis models. Well, many companies have used forecasting and scheduling quantitative models. You'll see in a later chapter that people claim that we haven't had a recession because we've been using better forecasting and better inventory models globally, and therefore have not built up the inventory glut that precedes many other recessions. This is all due to big programs, big ERP systems like SAP and Oracle, and our mastery of those techniques on a larger scale. NBC TV increased revenues by over $200 million between 96 and 2000 by using quantitative analysis to develop better sales plans. Well, we all know about quantitative analytics and how it's being used now for companies to try to maximize their revenue the best they can. In the airline industry, Continental saved $40 million in 2001 using quantitative analysis models to quickly recover from weather delays and disruptions. This is a model that we'll talk about when we do linear programming. You know, when there's a weather condition in a major city, it delays flights all over the country. You wake up to the next morning with the planes, crews, and passengers being in not where they're supposed to be. So you need a massive, massive linear program to say, how can we get back on schedule as quickly as possible and get the crews where they're supposed to be, the right planes in the right places, the right crews in the right places, and of course, the people that were stranded to their destinations. So basically, you take some raw data. I mean, the model is very basic. You take some raw data, you manipulate that data somehow, and you come out with meaningful information that you can act on. So what they call quantitative analysis, a scientific approach to managerial decision making, in which raw data are processed and manipulated to produce meaningful information. I mean, if you want to automate your decision process and can make everything a yes-no decision, which I think most things can be, even complex decisions can be translated into a series of yes and no decisions, you have a wonderful device you could use. It's called a coin. Heads is yes, tails is no, and you can make decisions very rapidly and very quickly. The problem is the quality of the decisions are not the kind that you're looking for. So when we have a quantitative analysis or develop a quantitative model, we want to see something that will guide us and give us that meaningful information to make more correct decisions than wrong decisions. So quantitative factors, that, when you have this kind of analysis, are quantitative and qualitative factors. Quantitative factors are different investment alternatives, interest rates, inventory levels, demand, labor costs, anything that can be quantified, hence quantitative. Qualitative factors are more difficult to explain, and they include things like weather, pending legislation, knowledge about what customers and or competitors might be planning that you may have verified, may not have verified. Another qualitative factor is the managerial aspect. You could do a quantitative model, and if you have the kind of boss that says, nah, I'm not going with that, my gut feel tells me we're going to do this, you kind of have to do what the boss tells you to do sometimes, and that's a qualitative factor that you might not want to deal with always. So here's the approach. You define the problem, you develop a model, you acquire some data, you come up, you use that model that you developed to crank through the numbers and come up with meaningful information. So that's developing a solution. You test the solution, let's see if it works. You analyze the results. Did it work? And if it worked, you say, is this a model we want to use going forward? And you implement results. If you test the solution and it didn't work, you go back to the drawing board and develop the model. If you analyze the results and it's not what you wanted, you go back and develop the model again. So this is a iterative, continuous improvement kind of model. And even if you have a model, there are underlying assumptions to models. When you created it, you might not know what they are, but the underlying assumption might be current market conditions. People have I have some friends that were in a Forex trading business, and they had really good models, and they were making lots of money. There were some economic changes in the country, in the world, and all of a sudden, the model that they used, which was based on the assumptions before those changes happened, was no longer valid, and they lost a lot of money and couldn't figure out why. They thought their mojo had left them, but basically their mental model that they were using was no longer valid because the assumptions and the underlying structure of where their model had worked was no longer valid. So that's the case here. If you look at this again, this is nothing more than what you learned in the 5th grade. It's the scientific method. Do you recall the scientific method? And it was basically form a hypothesis, collect some data, verify the hypothesis. If the hypothesis is true, you can use it as a basis for making predictions about the way nature and science works. If it wasn't accurate, you go back and refine the model and keep iterating until you get one that works. So this is basically what you learned in 5th grade, except instead of applying it to, the rate of speed that a falling object drops at, or whatever else we do in science, the mixture of two chemicals that creates this reaction, we're applying it to business situations. But it's nothing more than a scientific method applied to business situations. So oftentimes, especially in quality improvement, which I have some background in, the quality gurus and pundits will tell you that developing a clear, concise statement of what you're trying to do and what you're not trying to do is very important. Even in this slide, it says it must be the most important and difficult step. Crafting your statement. What are we trying to solve? What are the parameters? What are the assumptions? What are we trying to solve? And also, what we are not trying to solve. So it's essential to go beyond symptoms and identify true causes. It may be necessary to concentrate only on a few of the problems or a core problem, and specific measurable objectives may have to be developed. Developing the measures is really tough sometimes. So you develop a model. It could be something as simple as a line. We will spend a whole week on regression in a 7-week class. And there are different types of models, scale models, schematic models. So a scale model is a smaller example of physical model. There's schematic models where you actually draw out what's happening. There's stochastic models in which you vary the inputs and look at what happens to the outputs. So a variety of things. Usually you have variables in the model, and their variables come under two general categories. Variables you can control and variables you cannot control. Variables that are input, which are independent variables sometimes, and the output variables, which are the dependent variables. Inquiring the input data. If you don't get good data, garbage in, even if you have the right process, you're going to get garbage out. So, it's an old adage, but it certainly applies here very well. So even if you have a good model and bad data, forget it. If you can't collect good data, your model is useless. Developing a solution. Well, there are some very complex models. Can you solve them? Most of the time these days, there are some very, very good numerical software programs out there. Most of them are embedded and included in specific examples in ERP systems like SAP and Oracle, but you have to solve the problem. How long does it take? Is it worth the effort? Can you collect the data? And then how long does it take to solve? Back when I was your age and first taking a class like this, computing time was a significant factor. It's not so much anymore for most problems that most people are going to deal with, but it can be for some of the more sticky problems. Like I'm sure that problem of getting the airlines back on track, it takes more than a few seconds to work through those equations. So you can solve equations, you can do trial and error, you can do complete enumeration of all the possibilities and pick the best one, or you can use an algorithm, which is a series of repeating steps to get to a solution. Also, which is fading away more and more in this world, but used to be the only way to solve complex problems, and we didn't even know what the equations were, is something called heuristics, where you basically use experience and some know-how. Bus schedules, for example, for city transit. Well before their computers, people were planning and using bus schedules. There would be a big whiteboard and magnetic things, and they would put the buses on there and try to figure out how many people were taking which buses and which times, and the experienced scheduler would move these things around and tweak it and end up with a schedule with not necessarily using an algorithm, but using his experience and a heuristic technique. So then you test the solution. Well, both the input data and the model should be tested for accuracy. Is it, put some data in it, vary the data. Is it giving you what you expect from known entities, from your experience, from what you already have seen? You want to test things. When we do forecasting, we're going to use old data where we already know the answer, we already know what happens, and forecast, like we'll forecast December 2019 using all of 2018 and 2019 data up through November or up through October and try to forecast December. Well, it's well after that, so we already know what the December results are. and we can then see if our model was was accurate. We can test our model that way. We can go back in history and try to predict different months using the same model and just see how good we were at it. So results should be logical, consistent, and represent the real situation. And who's the biggest judge of that? You, the person that's developing the model, and those people that will be using the model. So you analyze the results, you determine the implications of the solution, implement the results. May require a change in organization. Oftentimes, if you solve something like this and try to get people to use it, it becomes a organizational issue and not so much a mathematical issue anymore, because people are stuck in their ways and are afraid of perhaps trying and implementing new things. So even if you found a solution or a model that works, you have this thing called backsliding, where it goes back to the way that people are used to doing things. A friend of mine used to say almost everybody in organizations are cave people. CAVE being an acronym for Citizens Against Virtually Everything. Sensitivity analysis, like when I talked about the Forex situation, if some of the underlying assumptions change, or the kinds of inputs vary from what you've been normally seeing, is the model still stable? Does it still work? You might want to look at that. So this sensitivity analysis, vary the inputs and see if the outputs do what you expect them to do. And then implementing. Again, as referred to in the previous slide, as you can see here, implementation can be very difficult. The cave people are resistant of change. And as mentioned before, quantitative analysis efforts have failed because good workable solution was not properly implemented. And that's really the job of management, to make sure that that's done. It could be a manager, it could be a director, it could be a VP, it could be the company president themselves, depending on how extensive the model is that you're trying to implement. So changes occur over time, so even successful implementations must be monitored to determine if further modifications are necessary. Having the right mathematical quantitative model is certainly a good thing to have, but then you've got to make sure that the socio-tech part, the socio part of the socio-tech system works. And then modeling in the real world. Well, yeah, you could always have an esoteric model that theoretically should work, but quantitative analysis models are used extensively by real organizations to solve real problems, and increasingly so. ERP systems have increased the amount of data available to people operating data from their company. It's mushroomed and exploded to such a high level that a lot more quantitative analysis is available, and people have dedicated entire careers now to what we call business analytics. So this is scratching the surface of that other field. So let's look at a very simple quantitative model. It's a mathematical model of profit called, I just call it the cost revenue profit model. Sometimes I refer to it as your crazy uncle problem. And I'll explain more on why I call it that. And the basic assumption of this model is that we're going to use the linear equations. Y equals mx plus b. Oh my God, 8th grade algebra comes back to haunt you. And we're going to look at this. We're going to look at profit as revenue minus fixed cost plus variable cost. And then profit is the selling price times the number of units, so it's this S times X, and then the cost equation is the fixed cost plus the variable cost times X. So X is the number of items you're going to produce and sell. So if you have profit is the selling price times X, minus, remember, even in quantitative analysis, it's not a math class, but the distributive law still works. The negative sign has to distribute over the F and the Vx. So it becomes S of X minus F minus V times X. Well, we have two X's. We probably should use the distributive law in reverse, which I think we will do on the next slide, actually. So this is the kind of problem you want to solve. The parameters in this model are three things: the fixed cost, the variable cost, and the selling price. The decision variable of interest is how many we're planning to sell. X. That's it. Some people use Q for quantity. So the company buys and sells and repairs old clocks. Rebuilt springs sell for $10 per unit. The fixed cost of the equipment to build springs is $1,000. Maybe it's the loan payment you have to pay on this machinery that you bought. The variable cost for each spring is $5 because you have to buy some wire that's going to be turned into a spring. And basically, building a spring is a coiling device that takes some really stiff wire and basically coils it into a spring. And the metal of the wire has to be stiff, but it also has some bendy properties or it won't become a spring. So here, S is 10, F is 1,000, V is 5. V is the variable cost, which is usually materials, labor, and maybe utilities that are required, some electricity or whatever it is you use. The fixed cost generally is the cost that you have to pay if you don't make anything. If North Park is not open the whole month of January, there are still costs North Park has to pay for security, for heating, for lighting, for any mortgages, any loan payments they have. That's all fixed costs. And then S is the selling price. Now here's why I talk about the crazy uncle problem. S is the selling price. V is the variable cost. You've all been at Thanksgiving or some other holiday where you have a gathering of your families, and we all have at least one of these characters in the family. I have a couple in my long history of family relations that always have some get-rich-quick scheme. You know, I want to make something. I want to make these gizmos, and I want to sell them. Well, Uncle, how much are you going to sell them for? I'm going to sell them for $15. Well, how much do you think it's going to cost you to make them? It's going to cost me $20 to make them. In materials and labor. Really? $20. And you're going to sell them for $15. So you're taking a loss on each one of $5. Well, yeah. Well, how are you going to make money then? I want to make it up on volume. Interesting. If the selling price is below the variable cost, you will never make money. I don't care how much volume. The more you make, the more you lose. And the whole game of this is, and I'm trying to see, yeah, the next slide actually tells it. The quantity you need to break even is the fixed cost divided by S minus V. So the break-even point, fixed cost, is the selling price minus the variable cost per unit. This is called the margin. How many times you have to divide the margin into the fixed cost tells you the number of units you have to sell just to break even. If the selling price is below the variable cost, you will never achieve that break even. You'll only lose more and more money. So what they did was they did this, and if sales are 0, the profits is minus 1,000. If the sales are 1,000, the profits will be 400. So we go to this point of break even where we solve it like this. So profit is, this is actually 0, but if this was P, it would be the margin times X minus the fixed cost is going to be the profit. When the profit is 0, that's called a break even, and you get this equation, you add F to both sides, then divide by S minus V, and here you have that equation. So in this problem, his break even, he has to sell 200 units. Anything less than 200 units will result in a loss. Anything over 200 units will result in a profit. That's wonderful. But one thing that this model doesn't show here is we don't want to just break even. I would like to make $1,000, $2,000, $5,000, $10,000 a month. in a small business like this. So instead of putting 0 here, you put what you think you want to make, and this will tell you then how many you have to sell each month to make that amount. And this is a very simple model. Remember, there's only 3 parameters: F, V, and S. Fixed costs, variable costs, and selling price. So is it incorporating all the costs? Does it have overtime? Does it have this, that, the other thing? It doesn't. It's a back of the envelope way of calculating something. And it's the best way when you're dealing with your crazy uncle or wacky sister or whatever it is at the holiday with their get-rich-quick scheme. You can ask a few simple questions and make an estimate of the fixed cost, the selling price, and the variable cost, and give them some idea, some scope of, will it ever be profitable? What will it take for them to break even? What will it take for them to sell? How many do they have to sell in order to make the kind of profit they think they can make? So, what's the advantages of this mathematical modeling? They can accurately represent reality or approximate reality. They can help decision makers formulate the problems and gives us insight and information that we might not have seen. They can save time and money in decision making because you can consider several options very quickly if you have a model that's easily solvable and can give you the answers. And a model may be the only way to solve really large, complex problems in a timely fashion. And they can be used if everybody understands a little bit of the mathematics behind it. They can be used to communicate problems and solutions to other people. If you solve it here and another division of your company has the same kinds of issues, they could change the parameters maybe and use the same model structure that you've created. We calculate models into 2 general categories. Mathematical models that don't have risk are called deterministic. All the values in the model are known and with complete certainty. If you don't know all the values in the models, even the parameters, sometimes, you end up with a stochastic or probabilistic model in which now there may be a distribution involved with some of the parameters or some of the variables, and it becomes a little bit more difficult to solve. The basic equation structure might be the same, but the solution involves some knowledge of probability and statistics to take advantage of these probabilistic or stochastic variables. In this course, we use, it comes along with a tool called QM for Windows. This guy from the University of Pittsburgh, I believe, or Carnegie Mellon, I can't remember which one, developed this model and has sold it to Pearson that they use for this book. We're using an out-of-print book, but we still can access the model and use it. And it's an add-on to Excel. And for many of the methods that we use, it saves you time and energy by not having to program the actual model. So I don't know how many of you will be model developers as you move forward, but I would say for the greater part of people that take a class like this, they will probably be accessing models that exist in other software, from Excel to ERP systems like SAP and Oracle. There's a couple different versions of it depending on if you're using a Mac or you're using a Windows computer, but it's always in add-ins and there's directions. The syllabus leads you to a website where you can download it and then you open it up, and I can show you kind of how it works maybe in another video. And it gives you all, either by chapter or by subject area, all the things that we're doing. So like next week, we're going to work on, there's break-even analysis if you want to do that. I don't know that you need this for that simple model, but you have to do it. Decision analysis is what we're going to do next week. That is really useful for that chapter. Regression, I'd rather just use Excel by itself, but you could use regression here. Inventory, this is worth using. We're going to cover that. So I would strongly recommend downloading QL. Do you have to use it all the time? If you want to program things yourself and learn more, have at it. I do insist, and there's a video that I will post also, of how I want you to use Excel and convince me that you know what you're doing in these models. And I'm a little bit stickler when I grade it. I will take points off if you don't follow my directions in that. It takes a little bit more effort, but I also want you to get in the habit of having your Excel output ready to go, ready to cut and paste into a PowerPoint, should you ever need to do that. So here's like using a break-even analysis. Fixed cost, you put some inputs in. You put in 1,000, you put in a variable cost, 5, you put in a revenue. You can put in a volume that you think you want to sell and you want to check. And then down here it spits out the answer. It gives you the break-even point, and it gives you the profitability at the volume that you asked about. So to sum up this chapter, possible problems in a quantitative analysis approach. Problems may not be easily identified. There may be conflicting viewpoints of what it is you're actually trying to solve. Like we said earlier, you have to resolve all of that ahead of time. There may be an impact on other departments or other functional areas in which you're going to have to involve them. The beginning assumptions may lead to a particular conclusion. Those beginning assumptions could change over time, so you have to be aware of that. The model is only as good as if the assumptions that you have still apply. And if it doesn't, then the solutions you get will be outdated, which probably means wrong. And if you're making wrong decisions, that will impact your business performance, be it profitability, whatever you want to call it. So the other thing is that there's no need to necessarily make really complex models. The easier you can make the model, actually, I think, is the better. It has to be complex enough to get you the solutions that you can live with, but not overly complex. Some people get all excited about convoluted and big models and all kinds of stuff that no one can follow because it gives them a sense of, well, you don't understand this, well, I'm indispensable then, you need me, kind of thing. Also, the manager, let's never forget the manager or the management. They may have a completely different viewpoint. I don't believe that darn thing. I've been in this business for how long, and I know what the results are going to be, and you can't tell me, and blah, blah, blah. You would think in this day and age there's less of those managers, probably so, but they still exist. Can you acquire the right data? We've talked about that. Can you develop an appropriate solutions? The mathematics may be hard to understand, or having only one answer might be limiting. Actually, most of the time, managers only want one decision. Tell me the number. Don't give me a range. Testing the solution for validity, we talked about that. Analyzing the results in terms of the whole organization may be a larger perspective. So implementation is not just the final step. You think that when you implement it, you're done. No, you've got to make sure that you've got continuous improvement mentality and maybe even a formal review process involved. Because models need tweaking and they need constant continuous improvement. What if you start using it and you can find a better way? Because you're kind of always looking at it and kind of always wondering and questioning. So management may fear the use of formal analysis processes will reduce their decision-making power. That's where the manager, we've talked about that before. Action-oriented managers may want quick and dirty techniques. Give me a quick answer. Don't time spent collecting data and doing all this stuff. You're not actually showing a bias for action. You're showing a bias for analysis. And they'll use words like analysis paralysis. We got to make decisions fast. Well, don't go to the system where you just flip coins and make lots of fast decisions. But, you got to, quick decisions are great. You've just got to manage how dirty those decisions are. Dirty means, are they accurate or inaccurate? Management support and user involvement are important. I think we've come a long way, and ERP systems like SAP and Oracle have helped a lot because they embed a lot of this inside of them, and it's just the way business is done. But still, these are issues that have to be managed. The analyst should be involved with the problem and care about the solution. Analysts should work with the users and take their feelings and experience into account. And that's it for this first chapter. Thank you very much for paying attention, and look forward to speaking to you again in other videos. Thank you very much.
Grammarly has become such a lifesaver for me when writing papers because it's essentially like a digital writing assistant. Once you download it as a browser.
Okay, to summarize, the discussion of our first module, quantitative analysis in finance actually is an approach that emphasizes mathematical and statistical analysis to help determine the value of financial assets, such as a stock or options. So quantitative trading analysis use a variety of data, including historical investment and stock market data to develop trading algorithms and computer models. Actually, that is for finance, and quantitative analysis involves quantifying of data with the help of some form of statistical analysis. So quantitative analysis generally involves statistical techniques like significance testing, regression analysis, multivariate analysis, and others. The statistic solution is the country's leaders in quantitative analysis. So the quantitative analysis measures quantitative data categorized as functional informations. So quantitative models use metrics based on facts and numerical figures such as statistics, formulas, and percentage. So calculating the sales revenue of one of your products is an example of quantitative data. So I think that's it for today, and next meeting, I'm expecting that your president will assign a topic per your classmate, and we will be able to discuss it next meeting. So thank you for attending our class, and good day once again. Stay safe, everyone.